All right, lesson 74, back to distance problems. Okay, in case you didn't hear any of that, I forgot to put my headphones in. Lesson 74, uniform motion problems with both distances given. So we are back to distance problems. Let's just review the kinds of distance problems that we've covered so far. We have equal distance problems where we have the distances are equal, so you would have distance A equals distance B, and then you would do rate A time A equals rate B time B. Okay, that's the distances are the same. This is where you're going to add the two distances up to equal a given distance, like 120. So you would say distance A plus distance B equals 120, and then you would do rate A time A, rate B time B equals 120. And then this is the third type that we did. We would say the distance of A plus 40 is going to equal the distance of B. Now the kind we're going to do today, both distances are going to be given. So these kind of problems that we're going to use two different equations. Trying to write fast here. These were just one equation. These are going to be two. So let's read the first one. Friar Tuck rode 24 miles to the fair in Nottingham at a leisurely pace. He stayed too long at the fair and had to double his speed on the way back in order to get home in time. If his total traveling time was 9 hours, how fast did he travel in each direction? What were the times? You'll notice here they tell us the distance. So that's the difference between these two problems. They're telling us the distance both ways. So we're going to have two equations. We're going to have the distance going. This is the distance going. And we have the distance back, and this is 24. So if you're drawing the picture right away, you're going to see that what type of problem this is. This is the distance back is 24. So we're going to have the rate going times the time going equals 24, and the rate back, the time back, also equals 24. So we have two equations. These should look familiar. Do you remember the advanced substitution problems that we had? This would, they did that so that you can do these distance problems. Okay, let's write some more equations. Already we notice we have 1, 2, 3, 4 variables. So we're going to need 4 variables. Tell us we're going to need 4 equations. So let's see if we can go find ourselves some more equations. So he stayed too long in the fair and had to double his speed on the way back. So the rate back is equal to 2 times his rate going. So we're down to, now we have 3 equations. We only need 1 more equation. And it says his total traveling time was 9 hours. So time going plus time back equals 9 hours. So now we have all 4 of our equations. We're ready to do our substituting. So here we go. So we're going to start with this equation right here. So we're going to take our rate back, our time back equals 24. And just start substituting. Our rate back right here, see this one, is equal to 2 rate going. And our time back right here is a time back. Its time back is equal to 9 minus time going. So I'm going to put that right here. 9 minus time going equals 24. So we used this equation. We use this equation, we use this equation, and you can just see when we distribute this one through, we're going to be able to substitute a TG, RG right here. So let's distribute that. So we get 18 RG minus 2 RG TG equals 24. Now we can substitute for this. So we get 18 RG minus 2 times 24. and we used our final equation up, equals 24. And if I just continue to solve this, I'm going to get 18 RG. Well, let's just get on to the answer here. You're going to get RG. Oops. RG equals 4 miles per hour. And then the question's asking what were the times? Well, let's see. The times, how fast did he travel in each direction? Well, the rate going was 4 miles per hour. The time going was, it ends up being 6 miles per hour. Let's see, where's the equation for that? Yeah, because the rate times time equals 24. So if the rate going was 6, we would need the time going, whoops, right over here, this one, the time going to be 6. So 6 times 4 gives you the 24. Then you just have to go back and substitute everything in. They want to know what the times were. Well, we know rate times time, the time going was 6 hours, time back 3 hours. Okay, that's all they wanted to know. And the rate back would be 8. If the rate going was 4, the rate back is 2 times that, so it would be 8. So hopefully get it. We're going to do one more. I don't want the video to be too long, so I'm going really fast. Okay, Atalanta. Yes, that's not a spelling. That's not a typo. That's how they say it. Atalanta could run 4 times as fast as her challenger could run. In fact, she could run 80 miles in 2 hours less than it took her challenger to run 28 miles. How fast could each of them run, and how long did they run? So we're going to set up our little thingies. So here we go. We have the first one was 80 miles. In fact, she could run 80 miles. So that's our first one. At the same, which took 2 hours less than her challenger to run 28 miles. Okay, this time they're giving you 2 different distances. The last one they gave you two of the same. There's 2 different ones here. All right, we're going to set up our little equation. Rate Atlanta, time Atlanta equals 80. Rate Challenger, time Challenger equals 28. Now we have to go get 2 more equations because we have 4 variables. We know that the rate of Atlanta was 4 times the rate of the Challenger. And we also know that the time of Atlanta was 2 hours less than the time of the Challenger. So we have our 4 equations just from this thing. The hardest part is to figure out what kind of distance problem you're talking about. When they give you the distances, you want to use this kind of problem. Okay, so now we just take one of our equations and start plugging it in. We're going to start with that one. So rate Atlanta, time Atlanta equals 80. Let's see what we can plug in. Rate Atlanta is 4 our rate of Challenger, so we use this one and we use this one. Time Atlanta is right there, is time Challenger minus 2 equals 80. So we use that one. Now when we distribute, we're going to get 4 rate Challenger, time Challenger minus 8 rate Challenger equals 80. And then you can see we can plug that right in there. These work out pretty easily. 28 equal minus 8 rate of Challenger equals 80. And then we just solve that all up. We're going to get 32 equals 8 rate of Challenger, and divide both sides by 8, and we get the rate of the Challenger equals 4 miles per hour. How long do they run? Well, the time Atlanta, if we have rate times time, rate Atlanta, time Atlanta equals 80. We have, well, the rate of the Challenger was 4, so the rate of Atlanta would be 16 because it's 4 times that. So we'd have 16 time of Atlanta equals 80. So the time of Atlanta would equal 5 hours. And the time of the Challenger is 2 hours more. would be 7 hours. So give those a try and hopefully these will connect. These are the complicated ones because we have these 4 equations. So that is it for lesson 74.